Hi everyone. Welcome to this Kubernetes overview. I'm RESTful, and today, we'll explore what Kubernetes is, what it does, and how it works. Here is the list PF content which we are going to cover in this video. Hope you will not mind to listen me. Here we go. Introduction focus points are: who am I? What is Kubernetes? What does Kubernetes do? Architecture focus points are: master components, node components, additional services, networking. Concepts: looking, what we get, core workloads, network storage, configuration, auth and identity. Let's continue to the next slide in the video. Hope you will capture the flows. Kubernetes, often called K8s, is an open source container orchestration platform initially developed by Google. It automates deployment, scaling, and management of containerized applications. It's inspired by Google's Borg and Omega systems and is now the industry standard for managing microservices. Kubernetes was designed from the ground up as a loosely coupled collection of components centered around deploying, maintaining, and scaling applications. Intro: what does Kubernetes do? Kubernetes is the Linux kernel of distributed systems. It abstracts away the underlying hardware of the nodes and provides a uniform interface for applications to be both deployed and consume the shared pool of resources. With Kubernetes, you can white check mark, run applications at scale. White check mark, auto heal failed containers. White check mark, manage networking and storage. White check mark, deploy seamlessly across cloud and on-premise infrastructure. Masters acts as the primary control plane for Kubernetes. Masters are responsible at a minimum for running the API server, scheduler, and cluster controller. They commonly also manage storing cluster state, cloud provider specific components, and other cluster essential services. Nodes are the workers of a Kubernetes cluster. They run a minimal agent that manages the node itself, and are tasked with executing workloads as designated by the master. Let's see in details in next slide. The image representation shows the different components of the Kubernetes within user interaction. Master components includes following: kube-apiserver, kube-controller-manager, cloud-controller-manager, kube-scheduler. Kube-apiserver, main API interface for communication. Acts as the front end for the Kubernetes control plane. Handles RESTful API requests from users, kubectl, external systems, and internal cluster components. Serves as the communication bridge between cluster components. Ensures authentication, authorization, and admission control. Acts as the front end for the Kubernetes control plane. Handles RESTful API requests from users, kubectl, external systems, and internal cluster components. Serves as the communication bridge between cluster components. Ensures authentication, authorization, and admission control. It is the true core of Kubernetes, acting as the gatekeeper to the cluster by handling authentication and authorization, request validation, mutation, and admission control, in addition to being the front end to the backing data store. Let's see ETCT, a cluster database, providing a strong, consistent and highly available key value store used for persisting cluster state. A highly available, distributed key value store stores all cluster data, including configuration and state information. Ensures data consistency across all nodes. Kube-controller-manager is described here as: the controller manager is the primary daemon that manages all core component control loops. It monitors the cluster state via the API server and steers the cluster towards the desired state. Manages multiple controllers that regulate cluster state. Includes different controllers such as: node controller, handles node failures. Replication controller, ensures the correct number of pod replicas are running. Endpoints controller, manages service endpoint objects. Service account and token controllers, manage access control. Cloud controller manager interfaces Kubernetes with cloud provider APIs, AWS, Azure, GCP, etc. Handles cloud-related operations like load balancers for services, persistent volume provisioning, managing cloud resources. The Cloud Controller Manager is a daemon that provides cloud provider specific knowledge and integration capability into the core control loop of Kubernetes. The controllers include node, route, service, and add an additional controller to handle persistent volume labels. Kube-scheduler assigns pods to worker nodes based on resource availability, affinity, and constraints. Ensures load balancing and optimal resource utilization. Takes into account factors like CPU, memory, and custom scheduling policies. Kube-scheduler is a verbose policy-rich engine that evaluates workload requirements and attempts to place it on a matching resource. These requirements can include such things as general hardware reqs, affinity, anti-affinity, and other custom resource requirements.